Okay, we're going to learn about what are called deliteral equations. And deliteral equations, if you will write at the top, right under where it says notes and examples, if you'll put equations with multiple variables. Okay, it then says solve each of the equations below for x. Well, the first example that they have is just 2x minus 5 equals 13. And so we're going to solve for x. Well, this is just a two-step equation. So the two-step, we're just going to do the inverse of the inverse of subtraction, which is adding. Bring down this 2x, add those. And then the inverse of multiplying would be to divide. So we're going to divide both sides by 2. And we're able to solve it and see that x is 9. Okay, with the literal equation, it's a little bit different in that you have different variables. Like, let's look here. We have ax minus b is equal to c. The thing is, we're going to still use inverse operations to isolate the variable, but we're not going to simplify it down to just one nice and neat answer. Okay, so we still want to solve for x here. So that means I still want to get x over here by itself. So I need to move this subtracting b. So I'm going to add b here, and I'm going to add b over here. Those cancel, and I have ax left on that side. And over here, I have c plus b. I can't actually add those because they're not like terms. All right, I still want to get x over here all by itself. So I have to get rid of this a. This is a times x. So the inverse is going to be to divide by a. So I just divide that side by a and this side by a. That cancels where I have x. Now over here, I can't cancel anything out. So that means my final answer is just c plus b over a. And that is your final answer. You can't simplify it down to just one nice and neat answer. You're going to leave it in this form. Okay, so where it says to quick write, it says identify similarities and differences between the two equations. Well, a similarity is going to definitely be that they both use inverse operations to isolate. So let's write that down. Both use inverse operations to isolate. And that means to isolate your variable on one side by itself. So that's the way that they are similar. The way that they are different is it's not going to simplify nicely. You're going to end up having, and that's, due to the multiple variables. These different variables are different letters, and different letters are not going to, you can't combine like terms with it. So it does not simplify nicely due to the multiple variables. Okay, I want you to look at this one example. So if you'll put your pencil down now, and I just want you to watch, okay? You're not going to do anything here. I just want you to watch. And, okay, here we go. This is a formula. and its area equals pi r squared. Well, let's say that I want to solve for r. That means I want to get r by itself. All right, so over on this side, what do I need to move? Well, I obviously see that I need to move this pi sign. This is pi times r squared. So the inverse of multiplication is to divide. If I divide this side by pi, I have to divide this side by pi. These pi's cancel out. So over here, I have a over pi, and now it's equal to, and I still have r squared. Okay, here's the next part. I don't want r squared. I just want to solve for r. So I need to do the inverse of squaring something. So I want you to think back to like in 8th grade math when you did the Pythagorean theorem, and what was the inverse of squaring a number? And it's to find the square root. The square root of r squared is just r. But if you're going to do the square root of this side, you're going to have to do the square root of this entire side over here. So therefore, your answer is square root of a over pi. That is your answer. All right, if you will please, over on the side, under where it says one-step equations, I would like for you to now write this down. I'm going to go back over it as you are writing it, okay? Starting off, I would like for you to put just a equals pi r squared, because that is the formula. Okay, we want to get rid of the pi. It's pi times r squared, so we're going to divide both sides by pi. Everyone should be writing this down under one step, even though this is more than one step. Okay, then we just have r squared equals a over pi. We want to do the inverse of squaring, so we're going to do the square root. If you do the square root of this side, you have to do the square root of that side. And that gives your final answer as, if you can see this, let me write it down here just a little bigger. That answer should look like this. Square root of a over pi equals r. Now that's a harder example. So now we're going to do some of the examples in the paper just so you can see how they can be easier. Okay, so I'm going to come over here and let's look at a equals LW, and it says we're going to solve for W. So I want to get W by itself. This is L times W. The inverse of multiplication would be to divide. So if I'm trying to get W by itself, I'm going to divide both sides by L. And so now W is equal to A divided by L. And I'm going to write it kind of in cursive so that way it doesn't look like a 1. Make these cursive too, just so it doesn't look like a 1. I'm actually doing L. All right, let's look down at number 7. Okay, look at number 7. Okay, for 7, we have M equals C minus S. And so they want us to solve for C. Well, solving for C means we want to move this. Well, that's subtraction. So the inverse would be to add. So you're going to add S to both sides. So C equals M plus S. That's your final answer. You're not going to take it any further than that. Okay, you are now going to complete the rest of the page on literal equations.